That's fine. That's a concept, right? So we are on concentration of solutions. Now, a solution is a homogeneous mixture of what? A solute and a solvent. So when I put sugar in water, sugar is solute and water is solvent, right? I form what we call a sugar solution. Now let's look at concentration of solutions. Amount concentration. It is also known as molarity. Please, not molarity. Molarity. We have molarity there, right? In kilograms. Molarity. It is the amount of substance dissolved in 1 dm cube of a solution. Now that is a formula. C equals number of moles over the volume of what? Solution. Now C equals N over V. So when we use this formula, we can calculate the concentration of the solution in moles per dm cube. This is the only formula which can give you moles per dm cube. Amount concentration. Mass concentration. It is the mass of a substance dissolved in 1 decimeter cube of the solution. So it is a mass of the volume. So we have two formulas here, right? Mass over volume, and here we have concentration by molar mass. You normally see these formulas in most practical questions, right? When you are doing titration questions, right? Good. Now they will give you something, maybe a substance in the impure form. And you have to calculate the mass concentration for that substance before you can get the actual concentration by using this formula, right? So we have instances where we learn these formulas. And they are all formulas for mass concentration, right? It's just the mass of a substance dissolved in 1 dm cube of what? A solution. Now, let's see something here. 1000 cm cube equals 1 decimeter cube. It's the same as what we call 1 liter. When you take your sachet water, it's written 500 ml. And ml, this is milliliter. Milliliter. Milli in mathematics means divide over 1000. Are you okay? So it means the pure water or the sachet water that you drink is 0.5 liter, it's half a liter. But it is tagged 500 milliliter, ml. Are you okay? So anytime you see ml, this m here is tantamount to 1000. Okay? Divide by 1000. So it can be 500 times 10 raised to the power minus 3. Or physically writing, 0.5 liter, okay? So 0.5 liter is also what? The same as what? A dm cube. So a dm cube is equivalent to what? A liter. Application. 0.5 grams of sodium carbonate is dissolved in 300 cm cube of water to form a solution, right? So it dissolves in 300 cm cube of water to form a solution. Now determine the concentration of the resulting solution in I mole per dm cube, and I grams per dm cube, and I moles per liter. Okay, moles per liter. So the solution to our problem here. I have the mass, so you look on when I finish, you take a portion, right? I have the mass 0.5 grams, and I have the volume to be 300 centimeter cube. Now determine the concentration of the resulting solution. Now I have to look for the concentration in moles per dm cube. The only formula which can help me to get moles per dm cube is the amount concentration technique, right? So I know that I have C equals N over V. This is my formula. I don't know my number of moles, so I have to go look for the number of moles from that which I taught you number of moles, right? So you have number of moles equals mass over what? Molar mass. Now I have to look for the molar mass, right? Molar mass of what? Sodium carbonate. Now molar mass is given by the mass of 1 mole of a substance. Now this is sodium, it's 23. It appears twice. Are you okay? Carbon is what? 12. Oxygen is 16. It appears 3 times. That is why you have this, okay? So what will be the molar mass here? Compute everything here. So 106 gram per mole. Now this is the unit for molar mass. 106 gram per mole. This is the unit for molar mass, right? Okay. Now you have this. Concentration is what? N over V. Okay. Now I have my number of moles. Now what is my mass? 0.5. What is my molar mass? 106. Yes. minus 3. So this is the answer we are getting, right? So you are getting this mole. It is in the standard form, it doesn't matter, you don't need to convert it, okay? Just leave it. So concentration now is N over V. Now what did you get from your N? You see that? 4.71 times 10 to the power minus 3. That is mole. What is your V? Now anytime you are given a V, make sure you change your V towards dm cube. So this one will be changed to dm cube, right? It is just by dividing by what? 1000, okay? So 300 over 1000 will give you a 0.3 decimeter cube. Why? You have been asked to calculate in moles per decimeter cube. If you don't change your volume term, you end up in cm cube. You understand? That is why you have to change your volume term to decimeter what? Cube. So there is 0.3 what? dm what? Cube. Yes. Mole slash decimeter cube, yeah. So there is a bar. If you remove this partition sign, that is where you bring the minus sign there, right? Now the next one, I've been asked to find what? Grams per dm cube, right? Grams per dm cube, right? So mass concentration can be concentration by what? Molar mass. What's the concentration here? Now what is the molar mass? 106, yes. 1 point what? Now this is grams per concentration, right? Concentration is in what is it? Gram per dm cube now, right? Okay, gram per dm cube. Good. Now the third one. I've been asked to calculate the concentration of the solution in moles per liter. I have to know something. If my volume is 0.3 dm cube, you know it is equivalent to 0.3 liter. Do you believe that? Okay, so concentration N over V is the same N that we use, right? The same N, 1.71 times 10 to the power minus 3. It is mole, right? Now what is the volume? 0.3 liter. I'll get the same answer again, but it will be in mole per what? Liter. Is that okay? Welcome to concentration. And be very careful. I wrote two examples, two formulas for mass concentration. I told you the mass over the volume is when we are trying to get the mass of the substance from the impure form, okay, doing titration. And when you are looking for the mass concentration without any impure form of any question, you just use this. Are you okay? So that is when we use it. That one you only see it in the practical questions when you are doing it, right? Good. What mass of this? It means I'm looking for my mass. Will be required to prepare 250 cm cube. That is my volume, right? The volume term must be in what? dm cube divided by 1000. Yes. Is this 0.25? Good. Check. Now the concentration of the resulting solution is this. Now take note. This thing you see here, the same as what you say molar. Okay? You can write this like this, the same as writing this. Right? So this is molar concentration, right? That's after time, it's not molar mass, please. That's, if it's molar mass, it will be a symbol, so it can't be before the things, right? So, a mole per dm cube is molarity, it's the same as just molar, okay? So whenever you see this, it is also what? A concentration. Now, I've been asked to find the mass. Amount of substance equals mass over what? Molar mass. The molar mass of our sodium carbonate, I think we just found that, right? That is 23 by 2 plus 12 by 16 by 3, right? You're going to get 106 grams slash what? Mole. Now I've been asked to find my mass. So N equals M over what? The molar mass. So I can make my mass the formula here. Mass equals number of moles by what? Molar mass. Right? Good. Now what is the number of moles here? We don't know it. Okay. Then I think I still have to look for my what? Number of moles. You see that? So N equals mass over what? The molar mass. Good. Now, number of moves, no, I can't use this. I'd rather use concentration equals N over V, right? So that I can generate my what? N. So this is 0.15, and the volume is what? 0.25. So I cross multiply. Do you see that? N is 0.15 by what? 0.25. Yes. 0.0. Okay. So this is my number of moles. Are you okay? I've used a symbol for the unit MOL. If you want to spell the units out, it's MOLE. Okay? MOLE moles has a symbol called MOL. It's just by coincidence. Now, number of moles equals mass over what? A molar mass. Now, what is the mass? It is N by what? The molar mass. Now, what is the number of moles? The molar mass 1016. Compute 3.975 watts gram. Are you okay? Good. So when they ask you to find the mass, it is what to do. Right? We have the concentration, we have the volume, so I was able to easily get what? The N. Please know how to mix your parameters. Preparation of solutions. In preparing solutions, we have two methods, the assay and also standard solutions. Now let's first look at assay. Now, if you have seen an ACL bottle before, when you take the bottle, you look at the cover of the bottle, right? The side. You see some specifications, right? Some figures, everything there. The specifications you see on the bottle is what we call assay. Assay. And it's a full list of the experimentally determined purity. It has been determined already. That is why it has been recorded. Are you okay? Experimentally determined purity of a chemical, including its impurity. You see, you don't always just get a pure. There is a little impurity in it, right? For example, if I have a biscuit, the biscuit drops on the floor. I take my but there's more impurity on the biscuit, right? Even if I have to be there's no impurity, right? Even if the biscuit does not drop, just this. Even the air impurities still before I ingest them. All we know that. That's why we have ACL in our stomach to deal with those bacteria. So the following specifications on an ACL container is called assay. So when you check ACL container, you see mass per cm cube. It's called the density or the specific gravity. It's given by this. So you say it's like the mass concentration, right? And this percentage purity, 36%. So the ACL in the bottle is not pure 100, it's just 36. Good. Now the molar mass of ACL, 36.5 grams per mole, you know that, right? Now from this information, the concentration of the pure ACL can be calculated. Are you guys saying it now? Okay, so let's see an application here. So let's see. Now you are provided with a concentrated ACL, 36% weight over volume. Density this. That's the specific gravity, okay? I'll find how you will prepare a 500 cm cube of 0.1 molar. Is that no more per cube here? I'll be saying it. 0.1 molar molarity ACL solution from the concentrated solution. Now, let's see what we have here. Okay, I think we have everything here, right? Okay, how you will prepare? Good, so we are going to prepare. Let's see. So I have concentration of ACL. I'm going to use this density by percentage purity by 10. Always use this parameter. dp10. So in short, something like dp10 over molar mass. Okay, over the molar mass, right? So if you want to do this calculation, unless you go to first principle and get it, if not, it's very simple to use this way. So this is what we call dp10 over what? Molar mass. Are you okay? Good. So you can use this parameter always. Now let's go. Remember, now they said you will prepare this. It means this is a V2. You agree? This is what? A C2. Or is it a C1? Let me see. How you will prepare a 500 cm cube of, okay, that's a C1, eh? So this is a C1. That is the first concentration, right? Okay. We have everything here, okay? Good. So, let's see. So, concentration of the ACL is given by the density. 1.18. The percentage purity, okay? Percentage purity, that was what? 36 by 10 all over the molar mass. 36.5. Now compute this. So 11.6 volts for molar. Are you okay? Or it can be mole per dm cube, right? Any of the options that you want to use, okay? Good. Now let's say something here. So I have 11 points, whatever molar. So I have to. So I don't know my V1. Are you aware? You see, when you are doing assay, you measure some of your solution in volume. But we are doing standard solution, we measure our solute in grams. Are you okay? We are not there yet. We just assay. So you see that you have a concentration for this, right? Now, from the dilution formula, right? We have C1V1 equals what? C2 or V2. Okay? So C1V1, if I go to dilution, you can see this much, right? C1V1, C2V2, right? So V1 is what? C2, V2 or what? C1. I'm looking for V1. That is what I will measure to get this. Are you okay? Now, what is C2? 11.64. What is V2? 500, right? Okay. You can decide to change it to BM cube. And you see that we are using a CM cube measuring cylinder. Are you okay? Good. What is C1? Again. Now compute this. Again. 58 watts 200, right? 58200. 58200. Let's maybe have changed some parameter here. Let's go. You are provided with a concentrated ACL of density base. I'll learn how you will prepare a 500 cm cube of this. How you will prepare. This is a C2. Take note. How you will prepare. You have been given the targets. Okay? Good. There is a C1. Okay. So the parameter again here. Let's go. C2. V2. Yes, you see that when you are doing more concept, we normally change our volume term, right? I told you that during our measurements, we measure in CM cube. We use CM cube graduated apparatus, right? That is why I leave it like that, okay? Even if you change to DM cube, nothing will happen. Unless you'll be having your stuff in DM cube. You are not going to measure in DM cube. And you have to change back to CM cube again so I can measure. That is also there. Okay? What are you getting in C1? Now compute. 4.29, right? Centimeter what? Cube. Okay? Are you okay? Okay. Now, hence, to prepare, you still have preamble for the question. To prepare 0.1 molar ACl in 500 cm cube of solution, measure, you don't say weigh, measure 4.29 centimeter cube of the concentrated ACl, right? You see that? Into a little distilled water, say briefly, right? Into a little distilled water. Into a little distilled water. If this is a volumetric flux, so I find the same volumetric flux, fine. Into a little distilled water in the volumetric flux. And top it up to reach the 500 centimeter cube mark. Yes, I hope you are seeing what is going on. So I'll find how you prepare this. So I have to look for the concentration of the pure ACl. I have it. So I put it from dilution. You see, in dilution, the volume changes, but the amount of substance remains the same. The end. That's why we have C1V1 equals another constant C2V2. So I found V1. How did I know this is V1? I was asked to prepare a 500. So that's I have to prepare and get a 500. That's a last volume. So this is my initial volume here, right? So how do I do my preparation? Briefly. So to prepare 0.1 ACl in 500 cm cube of solution, measure 4.29 cm cube of this into a little distilled water, top it up to raise the 500 cm cube mark, right? You have prepared your standard solution. What it means is that when you take ACl raw, it's so concentrated that you can't use it. So you have to do what we call dilution, right? It's just like alcohol, 100% alcohol. You can't use it. You have to do dilution. So you have to do calculation, get something and measure, and know the amount of water that you add to get it. Are you okay? Good. So that is